Welcome back to our lessons on piecewise functions. The last video that we watched discussed how we evaluate a piecewise function, or if we're given an x equals 4, what is our output or our y value going to be from that function? Now we're going to talk about how if we're given a function, we would graph it. And we're also going to talk about the domain and range of these functions. So let's start with this first one. Negative x minus 4 is going to be our equation if x is less than 0. If x is greater than or equal to 0, then it's just going to be an x. So the way that I like to do this is I start by just drawing a dotted line of some sort. So I'm going to start with our first function here, negative x minus 4. So I'm going to go down to negative 4 where my y-intercept is. I'm going to put a little dot there, and this is just temporary. And then I'm going to use my slope here. Remember, there's no number in front of that x, so our slope's going to be a negative 1, and I'm going to graph this line. So down 1, over 1, down 1, over 1. Similarly, back 1, up 1, back 1, up 1. And here I have this dotted line here, right? So that's our line. And I just graphed our line. Now that's if it has no parameters on it. But in our case, our line only exists when x is less than 0. So this is when x is 0, right here. So my function can only exist when it's less than that. So it doesn't even exist at 0. So here at 0, I'm going to change it to an open circle. And I want to make a solid line when x is less than 0. So here I am going to create this solid line here. Add my little arrow to the end because it's a line that goes on forever. And then I'm actually going to erase all of the dots that are greater than that, because our function doesn't exist, or that equation doesn't exist in our function past that point. Now I'm going to look at the other part of our function here, and that's going to be this x. And that x starts here at x is greater than or equal to 0. But we don't have to worry about that. I can just start right at 0, and I know that my slope is 1, so it's going to go up 1 over 1, up 1 over 1, up 1 over 1. Similarly, down 1, etc. But I only want my function to exist when it's greater than 0. So here's our 0 again. So I only want it to exist there. So I'm going to have it exist at 0, and I'm going to trace my line to everything positive. And all of these little dots that I have that are over here, we're just going to erase them. Okay, because they don't exist anymore. So there you go. That's how you would graph the function. So you graph the line and then limit it to just the parameter. Now let's describe the domain and range of these functions, of this function. So the domain of this function, what we're going to do here is we want to look to see. Now remember, a function is going to be representing all the x values. So in this case, it's all of the x values less than 0 and all of the x values greater than or equal to 0. There aren't really any numbers that aren't included in there. So our domain here is all real numbers. Remember, we can write that with that fancy R that represents the set of all real numbers. We can use set notation by doing negative infinity to infinity, or you could write all real numbers. Now our range, remember, is our y values. And so looking at our y values, what I like to do, I can see that both of these lines, this is an arrow here, it goes on forever, as does this one. So because both of those go on forever, I know that the top end of my range is going to be infinity, because it's going to go on forever. Now I just need to know, what is the bottom? Where is it going to stop? And I can see right here, this is my lowest point. And what point is that? Well, that's negative 4. Now I just need to decide, now that I'm at that negative 4, whether I'm going to include it or not. Now if it's an open circle, we don't include that value. So I'm not going to include it. So using that set notation, I'm going to use that curved or that soft bracket, because it says we're going to come as close to negative 4 as we can, but we won't actually reach it. And that there is our range, because our function goes from this, from almost reaching negative 4 all the way up, and it goes on forever in that positive direction. So that there is kind of how you graph it and describe the domain and range. Let's look at one more example here. We're going to look at this function here. when y equals x plus 1 if x is less than or equal to 0, or negative x if x is greater than 0. So let's start here with this x plus 1. That's where I'm going to start. Now remember, we graph the whole line and then erase what we don't need. So I'm going to start at plus 1. I'm going to go up 1 over 1, create my little dotted line here so I know what I'm looking at. Okay, and then when doesn't my function exist? This says it does exist at 0, so I know I'm going to make a circle there, but it doesn't exist, so it's going to exist at less than or equal to 0. So it'll exist at 0 and every x value less than that. But these ones higher than 0, it's not going to exist there. Now the other part of our function is going to be this negative x, and remember, if there's not a number in front of between the negative and the x, there's an imaginary 1 there. So our function has a slope of negative 1x and an intercept at 0. So I have an open circle here at 0 because it doesn't include 0. And then I'm going to draw a line that has a slope of negative 1. So down 1 over 1, down 1 over 1. Here's my little dotted line there. We can go the same in the other direction. Now we only care about this function when x is greater than 0. So x is greater than 0 going this way on that x-axis. So I only care about these points that are on that side. These other points we're just going to erase because they don't exist. And there you go. That's that function. Now the domain and range of this function. Domain. Now remember, if it's a function, it has to represent all real numbers as possible inputs or possible x values. So our domain is going to be all real numbers or go from negative infinity to infinity. Now our range is the one that's a little tricky. Now I can see that it seems like our function is going to go on forever in that negative direction, right? This line goes down, this line goes down. So I know that my bottom end is going to be negative infinity because those go on forever in the y's. But what is the highest point on my y here? Well, it's going to be that dot right there. And what is my y value there on that dot? Well, that's a 1. And notice how it's a solid dot. So if it's solid, that means we include it. And as we include it, we want to use that hard bracket. So there's our domain and our range. And that, in a nutshell, is how you would graph a piecewise function. Check out the next video on how you would write a piecewise function when given the graph.